Hello, welcome in this webinar about what's new in Capella 1.2. Thank you for watching it, and I am going to try and explain in about a bit less than an hour what has happened this last year in the Capella ecosystem. So both on the core of the Capella workbench and globally on the ecosystem. I'm going to talk about evolutions that are pretty small, representing a few days of development, and about evolution that represented a few months or even a few years of development. So I'm going to start with the small Capella evolutions. They are small, but they are still worth being mentioned. So the first one is something that we have backported in the 1.1.2 version, and it's the in-place edition of constraints. Previously, to edit text with references towards other elements, like the one you need in guards of transitions, in conditions of sequence diagrams, and so on, you had to open 2 or 3 dialog boxes and then input your expression. Now, on the first page of each editor, you can write your text, do control space, and have access to all the elements of the model and create references so that when the referenced element will be renamed, then your expression will be renamed as well. So the goal of this is, of course, to reduce the unnecessary complexity and the having to open a few dialogue while we can do that in the first page. The second one, the second small evolution, is something that is a continuous improvement. We try to improve the context that we compute for each element. We try to make it more accurate, and some queries are still missing. But month after month, we're adding some queries. And on this example, it's, for example, the capability realizations in the logical architecture. So if ever you identify missing queries on some given elements, we invite you to use Bugzilla on the Eclipse website and then submit these requests. The next one is something that comes with the new version of Sirius, and it's called the Interpreter for Instant Queries. It's based on AQL, Axeleo Query Language, and it allows to compute basic metrics on models, and it's pretty useful to check the validity of AQL expressions, in particular when you generate documentation, and I will show that at the end of the webinar. So for this one, I'm going to do a small demonstration. I've opened the view in Capella, and I can select a given element, and here write an expression in AQL language. So this is pretty simple. Self is the current element. Then it requires to understand the language that is behind Capella. So I know that on a given structural element, I have a method that allows me to retrieve the functions. And now I have the list of all my functions here. If I want to go one step further and see, for example, the outgoing exchanges from these functions that are allocated to the system, then I can do that, and then I can count them and so on. So it's pretty handy to validate that one given expression is actually well formed. Okay, I'm going to go back to the slides. The next one is also something that we've backported in version 1.1.2, and we have been improving the consistency of interfaces in Capella. So basically, at functional level and structural level, we want the interfaces to be consistently defined, and we have developed some additional rules to do that with dedicated quick fixes. So for example, the one we see on the screen is we're checking the names of functional exchanges that leave from the same port. We're detecting the exchange items that are not used. We are detecting that exchange items allocated to different functional exchanges connected to the same port have similar content, and so on. So this kind of verification is really the essence of Arcadia and Capella. We want to secure the subcontracting, we want to secure the interfaces between structural elements and justify them with functional content. But in addition to these validation rules, we have also improved the accelerators that allows the generation of the component exchanges based on the functional exchanges and the generation of the interfaces based on the functional content. And this is something that is really powerful in Capella. So we're moving now to the more significant evolutions. Some of them have taken a few days, months, and some of them have taken a few years. Some of them are long-time missing features. First one is one that you've been asking for quite a while now, is the ability to have rich text descriptions in for model elements. So basically you can use bullets, you can use styles, you can use references towards model elements, diagrams, URLs, pictures, and so on. The goal of this is to enhance the readability of your models. And so this is now coming with Capella 1.2. It is still an add-on at that stage, and later with 1.2.1 or 1.2.2, this will be integrated in the core of Capella. The next one is something that really was missing in Capella, and we were lacking mechanisms to cope with the complexity for structural diagrams. So we had really advanced features at functional level, but we were missing the computation of simplifying links between components. So the goal of this is, of course, to help cope with the design complexity, and I'm going to perform a demonstration for that. So I have a model that I already created for this. I don't know why on Mac OS the activity browser doesn't always pop up, so this is something we have to investigate. It still pops up systematically on Windows. So here is a very simple diagram, and what I want to do is hide, or I don't want to show the internals of all my components, and for example I don't want to show these two subcomponents here. However, I'm still interested in knowing that there are connections toward this global behavior component B. So I remove these boxes, refresh the diagram, and now I have the component exchanges are displayed with a dashed style, and that means it goes towards internal components of BCB. The same goes for physical links. I can remove this PC1 here, refresh, and have a computed link. And we see on one side that we have the physical port because it really represents something. And we didn't display it here because the physical port belongs to one of the sub-components, which is a little bit different from the functional analysis. I'm going back to the slides. That was a demo. And I'm moving to something that took a few years to develop. Our systems are obviously more complex. Most of them have different modes, operational, connected, disconnected, and so on, and states, failed, nominal, and loaded, half empty, half full. And the combination of modes and state for one given system is pretty complex to master. So the question is, how can we analyze the expected functional content, and how can we relate our parametric analysis to modes and states? During these last 2 years, we came up with a methodological approach that we have integrated to Arcadia. and with the tooling that supports this. So basically, we have introduced the concept of configuration and the concept of situations. Configurations help specify whether things are available or not available in the system. We correlate the configuration to modes and states. And situations are Boolean expressions mixing modes and states from different state machines. The tooling allows to preview on architecture the footprint of one given configuration. The elements that are gray are the elements that are not available in the configuration that is currently displayed on the component. And then we have some validation rules and computation algorithms that help confront expected configuration versus the atomic configurations. So the goal is really to analyze the impacts of modes and states on system behavior. And now I'm going to perform a demonstration of this. So this is a model of CubeSat configuration. So I'm interested now in the transmission of data to the ground, and I want to see, for example, two functional chains that are related to the communication with ground. These two functional chains are these two ones, so coming from here and here. And I can display an expected configuration. So I have created a configuration that reflects the content of these functional chains. So I can select it and display it. The result is that everything that is not part of these two functional chains will be grayed because my interest right now is the content of these functional chains. I'm going to remove that. And I also have mode machines or state machines on different subsystems. So for example, on the communication system, I have three states. One of them is failed, and I have created a configuration to reflect that on the communication system. So basically, I select this configuration and want to preview it. And then on this component, I can see that when I'm in the failed state, these two functions are not available. So first of all, I can, using the preview on diagrams, I can confront expected configuration with the atomic low-level configurations. And I can compare them. So for example, I can take this expected configuration and this one, which are the two ones I just displayed. Right click, update, create a comparison. I have a comparison object that I can validate. And then the tool is telling me that there's something wrong. In this situation where the communication system is failed and I still want to transmit things to the ground, then I have a conflict between my two configurations. And the conflict comes from the fact that these two functions that are useful are not available. Next one is Capella diff merge. What we have done this year is to introduce advanced match and merge policies. No, I don't want to move right now. So basically, until now, we were able to compare models that had a common origin. And the comparison was exclusively based on IDs. Now you can customize the matching policies and then the merge. The goal is to be able to perform advanced refactoring of models and advanced maintenance operations. So to better understand the extent of this change, I'm going to move to the Capella environment. And we're going to do a very simple use case. We're going to create two different projects, compare them, and see what happens. So the first one is going to be project 1. Easy. So it's coming. I am going to create a very simple data flow diagram. Okay. And this data flow diagram will have, let's say, just 2 functions and 1 functional exchange. I don't touch anything. Okay, so I'm going to save this and close it. Create another project. Project 2. Finish. I'm going to create the same kind of diagram. It's here with the same functions. So function 1, function 2, a functional exchange here. But this time I'm going to create a second functional exchange. And this one, I'm going to change the layout, make it rectilinear, and do something like this. I save this and I close. So now I'm going to compare these 2 projects. So compare with each other as models. And that is the basic comparison provided by Capella. So it's ID based, but I can configure the matching method and say that now I want to transfer elements that comes from models that have been created independently. So I do that, and it's performing the merge. In the merge, I have 15 changes, and what the tool does is that it doesn't match function 1 and function 2 in both models. It considers them as distinct elements, but we can update the configuration policy, the diff policy, like going into advanced settings, and say that we want to match the names, and we also want to match diagrams whenever it is possible. So when I do that and I finish, it updates the differences, and now we can see that function 1 and function 2 have been reconciled in the 2 projects. But because we created a new functional exchange with 2 ports, then this is what we on the second diagram, on the second model, this is what we see in the differences. So what I'm going to do is to select these changes, bring them back in my first project, so moving them from project 2 to project 1, and going to do the same with the diagrams. Okay, and this one is probably just the name of the project, but I don't want to change that. So I just save everything and open my first project. When I open my first project, I go and check my data flow diagram, and what we see on the first project is that we have the new layout for Exchange 1 and we have functional exchange 2. So starting from 2 different projects, we've been able to merge them and transfer elements from one to another, which is pretty powerful when you need to perform advanced maintenance operation on models. So the next major evolution I'm going to talk about is everything that we've done this year on libraries and building blocks. By improving the user experience, we really went one step forward. So building blocks in Capella are managed through the record and replica concepts, and a replica conforms to a record according to compliance rules, so black box, constrained reuse, and inheritance, or you can also customize your own compliancy between them. And so what we did this year was to prevent accidental modification by introducing on-the-fly enforcement of the black box consistency between rec and repl, and we enhance the user experience to create rec with libraries. So what we had so far in Capella was a validation rule that was detecting that a replica needed to be updated because its definition, a rec in a library, had been updated. So this was what we had so far. What we have introduced in Capella 1.2 is the enforcement of the black box compliancy, meaning that we cannot add a function, we cannot add a port, we cannot add anything to the replica if it's not in its rec. The other compliancy verifications are not available yet. We are waiting for operational use cases for them. So the live compliancy enforcement is relying on a model validation rule that is a black box, and we can select for each replica whether we want to enforce this compliance on the fly, thus preventing accidental modifications. The other thing we did is we have introduced a feature that allows to create one record, with the whole content of a library. If you are, for example, in a scheme where you have one building block per library and you want to create a reference architecture by assembling all these building blocks, it is pretty convenient to go on a library and in one click create or update a rec. And I'm going to illustrate that in a demonstration. The goal here was to have really an easier rec management and to enable, to provide everything that was necessary for versioning, and you'll see that with Yuzu at the end of the webinar. So the demo. So I have two building blocks, platform A and platform B. I'm going to browse the content of platform A, which has content in all engineering perspectives, in system need analysis, logical architecture, physical architecture, and elements within all engineering perspective as dependencies towards the other elements. What I'm able to create now is a rec from the global library content, and I can name it platform A, and it creates a rec with everything that has been defined. I'm doing the same in platform B. In platform B, I create a rec with the whole content. We can see that I have only things in the logical architecture in this one, and I call it platform B. Now I have two building blocks, and I'm going to create a reference architecture. This reference architecture is going to have references towards these two libraries, so dependencies. And I add the dependencies here with manage references, and I select the two libraries. Now in this reference architecture, I'm going to instantiate my records, and I'm going to create two instances of platform A and two instances of platform B. So the first one here, we can see that we have a checkbox to enforce the compliance on the fly, and we also have a new feature that allows to locate elements directly in packages. Creating a second one, and we will have specific packages for the content, and then I'm going to instantiate one instance of platform B, which is done here. Now, if we check the content of our model, we can see that we have packages for all our recs, so it's easy to maintain them. And the same goes for components. And I'm going to create a logical architecture diagram in which I will show the content of these logical components, so coming from different building blocks. So I select all the components. Then display all the allocated functions and do a little bit of layouting so that we can understand what happens. So LC1 and LC1 are two parts of platform A. LC3 and LC2 belong to platform B. And we can see this with the semantic browser. Now, if I try to modify one of these replica, for example, by adding a function, the tool indicates that I'm violating the integrity of the model. The same goes if I create a functional exchange. So this is because my replica are in black box compliancy. However, what I can do is to create a link between ports that already exist, because I'm only assembling replica building blocks coming from different libraries. In addition to these improvements on rep, and libraries, we also have developed a new dialog that allows some refactoring between model elements. So you've probably seen that it's pretty difficult to move elements from a project to a library, or from a library to another one. So we have developed a prototype. So it's available in version 1.2, but it's still in incubation mode. And the idea is to be able to select a set of elements that you want to move from one model to another one, and perform this this move. And basically this view enables basic model maintenance. So I'm going to do a small demonstration of this. We need to display one specific view, which is called the move elements view, which is here. And on the left side, you're gonna select the elements that you want to move. So for example, I want to move the component LC1, and the tool analyzes that my project is depending on one given library, and some elements are displayed in red. That means that they are missing dependencies. So for example, I cannot move LC1 if I don't move the functions that are allocated to it. So I can select the two functions here, bring them here, and complete. So now it looks like we don't have any dependency issues anymore, but any element that is written in bold needs to be relocated in the target library. So our goal is to decide that LC1 is going to be under the logical system of, I don't know what, yeah, into the logical system of the library, and the functions are going to be located inside the root logical function of the library. Oh, sorry, I was, this was a little bit sensible. Yep. And now all the root elements of the thing that I want to move are green, and my I have decided where they're supposed to go in my target library, and the move button has become available, and I can now click and move the elements. So I can do that, and this is globally performed, and then I can proceed to a new one. The next big topic is diagram ergonomics. We know we all spend a lot of time all along the day to play with diagrams, and the team has really made a huge effort combined with the serious guys to improve ergonomics. First of the big evolutions is related to management of edges, and I'm going to illustrate that. We have also introduced some new decorators to specify that the diagram is synchronized or unsynchronized. We have improved the resolution of exported images, and in version 1.2.1 you will also have the ability to select yourself exactly the resolution that you want. And finally, we have significantly improve the dimensioning of fragments. So when you change the size of a fragment in the sequence diagram, it is now much easier. So I am going to give you one small example of this, and it's related to link management of the connections between elements. We all know this kind of problem here, where we have messy connections. So now what we are able to do in this version of the tool is to select all the edges and directly decide that we want to align them on the top, or we want to align them on the bottom, or we want to align them to the left, and then it's gonna work like this. We can also combine with existing features like the distribute features, so that there's the same space between all of them. And now that we have distributed, we can do that with the top aligned. So this is something that really is a time saver and it's something that was clearly missing in Capella until now. So back to the slides, and I'm going to move to performance. Performance is something that is continuously being improved. So the team has performed a lot of small things to improve the performance, and I'm not going to browse them because it's pretty complicated. I don't even understand all of them. What is important to notice is that on basic operations like inserting diagram elements into diagrams or refreshing diagrams and so on, all in all, we have really significant performance gain. The thing is to make our users benefit as soon as possible from these performance improvements. We have most of the time when it was possible backported them in the previous versions. That means this year already with Capella 1.2, 1.1.2, 1.1.3, you have already benefited from these evolutions. So there won't be a huge gap between 1.1.3 and 1.2. But basically, what you have to know is that between the version in January 2017 and the version today, there's a huge improvement. Next topic is documentation. I've written, read the fucking manual. Why? Because there's a lot of things inside. The team has made great efforts to improve the content of this documentation, and that was already the case for the last 2 years. Now when we open Capella, we have a more direct access to the help content. And in the help content, you can find really useful information. So for example, tips and tricks, you can basically have an explanation about all the different wizards and editors in Capella and so on. So really, I invite you to go there and read. And then if you don't find your answer, use the forums. Next evolution is version control with enhanced support of Git. So as I am not going to perform a demonstration of Git here, that might be the topic of the next webinar. I invite you to go, you know where, in the documentation. We have a long page of explanation of how to configure Git and the clients and so on, and do diff merge and so on. So go in the help and see how you can couple Capella models with Git to manage them in configuration. The next big evolution is not something that is on the open source product, but on the commercial add-on Team for Capella that is provided by OBO. And what we've been doing together with them is to enhance the change tracking in Team for Capella. So basically, we are now able to relate the working sessions on Team for Capella to Mylin tasks in Eclipse. Mylin tasks in Eclipse can be related to Jira activities if you have the commercial connector that goes with it. And then we are able to associate automatically a context to each of our commits in Capella. And the best is really to perform a small demonstration to illustrate how this works. And you will see that we are also able to compare the different commits. So we have user 1, user 2 on both sides. I think user 2 is on the left side. We see a list of the tasks that are registered in this repository. We can have the detail of one given task. So the first one is understand how it works. We're able to add description, we can give it a status, and so on. If you're connected to Jira, all this information would come automatically. And then in the preferences, you can specify whether you want to pre-fill the commit descriptions with the tasks information, and you can also specify the template for the information that you want to register. So we have the two users have opened the same diagram. We see the commit history on both sides, and user 2 on the left side is currently working on task 1. So is creating a few functional exchanges. So we see on the right side that the red locks appear because the user on the left side is currently editing them, is performing a commit. The diagram on the right side updates, and we see in the commit history that the commit has been associated to the task 1. Now user 1 on the right side is performing some renaming. His working context was task 3, and it was displayed, and then it has been updated on the left side, and we see that user 1 did task 3. Now user 2 on the left side is changing the status of one given task, setting it as complete. It appears in green in the task list, and defines task 2 as a new working context. And in this context, it is going to perform some changes on the model, like removing 2 of the functional exchanges. And on the right side, you see the elements are locked. And then when the user saves, we can see that the activity was actually task 2, verify the expected behavior. So this is, and now for each given element, you are able to display the history. So you can see who has touched one given element. And now we're trying to see what happened on the port. So there was much less activity on the port of the function, and so on. So it's when you are surprised about something that happened on one given element, it's easy to know the history and find for which reason something have changed. And now we're comparing two commits, which is pretty handy to understand the differences. And then you have a basic diff merge window, except that you cannot merge, but at least you can see that 4 functions have been renamed and some functional exchanges have been created. So this is pretty much all for this demonstration of Team for Capella. This is something that is commercial, and this is really a huge step forward to better track the changes on models. So now I'm moving to the ecosystem. The ecosystem is significantly growing, and I'm going to talk about 4 add-ons or 4 couplings around that makes Capella more useful. And the first one is documentation generation with this open source add-on M2Doc developed by Obeo. This M2Doc add-on allows to specify templates for documentation generation based on models. So within your Eclipse environment, you see your Word templates, and here we see the result of a documentation generation. And you can basically write your queries and your scripts within the template, within the Word document. So it's pretty simple. If you check this one, it means in this table, I'm going to have in the first cell the name of a functional exchange. In the second one, I want the name of the functional exchange source, the name, and the last one, the name of the function that is the target. And the bookmark ref is something like will enable hypertext links in the generic document. So it's not that complicated, and if ever you want to do advanced templates and so on, you can always contact Obeo, and they're providing service on top of that. The M2Doc website is pretty complete with installation instructions and sample of templates for Capella. The next topic is product line engineering. And I'm talking here about the coupling between pure variants, that is a feature modeling tool, and Capella. The integration of these two tools looks like this picture. You know the Project Explorer in Capella. We see a feature model with one specific configuration. So it's a weather station. We've chosen French. We didn't choose a wind speed sensor, and so on. And we didn't choose consultable on smartphone option. And then in the architecture, selecting these features and so on will have impacts. And what we are previewing in this diagram is what this diagram looks for this given configuration. So we're able to create variation points in the architecture. And for one given variation point, like consultable on smartphone, we can preview which are the elements that are related to this variation point or to this option. And these are the elements that are written in red with red borders as well. So the coupling between pure variant and Capella is now an official connector that is delivered with the Enterprise Edition of Pure Variants. Then we have the coupling between Safety Architect and Capella. Safety Architect is a tool that is developed for All4Tech, and it's dedicated to performing functional safety analysis. So what we have is for example, data flows in Capella, and there's an add-on, a viewpoint that has a concept, for example, of field event that we can associate to elements in Capella. We have a bridge that allows to retrieve in Safety Architect the data flow that was made in Capella. And in Safety Architect, the safety engineers will refine the functions, analyze the block local failure conditions, create barriers, and so on. In Safety Architect, there will be a generation of fault trees based on this modeling. And the fault trees that are obtained in Safety Architect can then be reintegrated in Capella as critical functional chains. So it's really a bidirectional coupling between the two tools. And what has been done recently is to scope the definition for the safety analysis. So instead of performing a safety analysis on the whole content of the model, we are able to select the scope that applies for the analysis. And that was one request from safety engineers. So everything is really driven by real project use cases. In Safety Architect, we can see the mapping. So in yellow, we have the physical component, the implementation physical component of Capella. In blue, the behavior component, and in green, the functions. But we are in Safety Architect. And finally, the most recent add-on is called Yuzu, and it's from Thales. And the idea of Yuzu is to provide a modeling store to better manage modeling assets. So in one given project, we might have many Capella libraries, we might have many different add-ons, viewpoints, and each of them have specific versions and so on. And managing the combination of all this is sometimes tricky. So Yuzu comes and brings solutions to classify, store, query, and retrieve modeling assets. It is based on the OMJ RAS standard. And what you can do is you publish your Capella project, so typically a library. You classify the project, you enter basic metadata, keywords, metrics, and you manage versions. So You can have 3-digit versions and so on. The model itself is stored on Artifactory repository, and then you can search for models, searching for keywords and so on, retrieve them, and when you open a model, for example, that had dependencies towards libraries, the tool will tell you, hey, I have a new version of my repository. Do you want to use this new version, or do you want to stick with the old one? So combined with libraries and building blocks, as I was mentioning previously, this is something that is pretty promising. The current state of this add-on is it's in its very early phases. It's version 0.9, and there's a roadmap for 2018. And if you're interested in this, please contact Arta. So this was a lot of information in not that much time. So now it's time to sit back and browse the list. Everything has been published on the Capella wiki. There's a release note dedicated to all these evolutions. But the best is, of course, to download and try. So this is available from the Capella website, for which I have given the address here. And what are the next steps? So as you've seen, the community has been extremely active in 2017. We are already working on exciting new features for 2018. We have tons of ideas, especially regarding assembly of building blocks and stuff like this. But we cannot always do everything on our own. And if you want to make things faster, or if you have also ideas for evolutions, consider contributing, providing bug fixes, developing add-ons, or funding evolution that Obeo or Thales or whoever would contribute to the tool. So thank you very much for watching this webinar. Here are the links, the website, the LinkedIn discussion group, and the different forums and so on. So thank you very much. Bye.